You were assigned 8 problems from homework. I'm going to do half of them. So you were assigned 4 through 10, 16 through 18, and 20 through 22, all evens from pages 494. I'm going to do problems number 6, 10, 18, and 22. So I'm going to start with number 6. So they give you 2 sides and 1 side is missing. So if you remember in a Pythagorean theorem triangle or a right triangle, you have 3 sides, A, B, and C. In number 6, they gave you B. B is 5. They gave you C. C is 10. And you're missing A. So they didn't give you the visual triangle, but essentially it works out the same way. So the Pythagorean theorem is A squared plus B squared equals to C squared. So we're going to plug in what we know into the theorem. So 5 goes in for the B, 10 goes in for the C, and A is unknown. So we're going to get A squared plus 5 squared equals to 10 squared. So the 5 and the 10 came from the B and the C that we already know. So then we get A squared plus 25 equals to 100, because 5 times 5 is 25 and 10 times 10 is 100. Then I'm going to subtract 25 from both sides, which gives me 75. So A squared is 75. Again, to get rid of that power of 2 in the A, you square root both sides. You square root the A to the 2 to get rid of the power of 2, and you have to balance out the equation by doing it to both sides. So that gets rid of the power of 2 and the root for the A. So A equals out to root 75. And you have to remember that this is not the simplest form, because 75 is made of 25 times 5, which is the same as root 5 squared times root 5. And just like before, you can cancel out the root with its power of 2. So the final answer to this problem is 5 root 5. So A equals to that. So that's the final answer. Once you get to this point, all you need to do is simplify. The 75 is 20. Oh, I'm sorry. That's 25 times 3. So that's a 3. That's a 3. My bad. So that's the final answer is 5 root 3. Alright, so that was number 6. Because 75 was 25 times 3, not 25 times 5. Let's do number 10. I'm not going to draw the triangle this time, but they give you A is 7. They give you C is 25. And they're asking you for B. B is a question mark. No problem. The Pythagorean theorem is A squared plus B squared equals to C squared. Plug in what you know. 7 for A, 25 for C, and we don't know what it is for B, so B remains as is. 7 squared plus B squared equals to 25 squared. So in this case, you have to do your math. 7 squared, that's 49. B squared, that's going to stay as is. And 25 squared, that's 625. Then you're going to subtract 49 from both sides to isolate B. So I'm subtracting 49 from both sides. I'm going to continue the problem over here. So B squared is going to be equal to 625 minus 49, which is 576. We are getting some larger numerical values here, which is going to make solving this particular problem a tad bit more difficult. We'll see. Then we have to square root both sides to get rid of that B power to the second. And then we're going to cancel out the power of 2 and its root. So that leaves our b all alone, which is exactly what we always want, being equal to the square root of 576. Now, that's a big even number, so there's probably going to be square roots or perfect squares under there. Now, what you might not recognize right away, and I wouldn't give you a problem this numerically large on the quiz, is that's actually a perfect square. It's a perfect square of 24 times 24. Again, I don't expect you to memorize that on the quiz. I wouldn't give you something that's quite that big in terms of being a perfect square. But for this particular homework problem, I guess it's fine. And since it's a perfect square, it's 24 squared, we can cancel out its power of 2, which that means that b is 24. Even makes sense. A, the shortest side is 7, b, the middle side is 24, and c is 25. While the hypotenuse isn't much longer than b, it's still longer, so it makes sense. All done. Good. Now let's do number 18. Number 18, they give us this picture. I love pictures. It reminds me of geometry. Alright, so they give us this triangle. They tell us that the base is 14 and that the triangle right here has a midpoint. So this is a midpoint right here. That's a midpoint, which means it splits the triangle in half. So this half, even though pictorially it doesn't look like it, they're equals. This half equals to this half as far as the base goes. So that means you can split these up into 7 and 7. Terrible sevens. They also tell you that the height is 9. So they told you that the entire base was 14, but that this right here is a halfway point, which means the base is split into 2 halves of 7 and 7. The height is 9, and this side is missing. And if you look at this triangle, you'll see that this is the hypotenuse. It's the longest side, so C is missing. They gave you one of the legs, which is 9. They gave you the other leg because it's half of the entire base, which is 7. So then you're going to find the missing side, the C. They said x, but the x is indeed the hypotenuse. So the Pythagorean theorem is a squared plus b squared equals to c squared. Plug in what you know. You know that one of the shortest sides is 7 squared. The other middle side, or the other short side, is 9 squared, and we don't know what the longest side is. 7 squared is 49. 9 squared, that's 81, equals to c squared. Now, go ahead and crunch your math, and you will see that 49 plus 81 equals out to 130, equals to c squared. Then, of course, we're going to go ahead and root both sides. And once we do that, we find out that, well, we can cancel out the power of 2, of course, with its root. We find out that c equals to the root of 130. I'm pretty sure that's not simplified all the way. Unfortunately, 130 doesn't really come out very evenly when you get its factors out. 130 is made of 2 times 65, and 65 is made of 5 times 13. So we run into a dead end. There are no perfect squares inside 130. So that's about as good as it's going to get. Looks like there should be a perfect square. It's a nice even number that's big, and you would think there would be a perfect square under there. but there isn't one. So the book is asking you to round your answer to the nearest tenth if necessary. I'm fine with this. If you get me this out of this problem, I'll be ecstatic. So that's number 18, and that is being the answer that I'll happily accept from you. Last problem, number 22. Alright. This is the converse Pythagorean theorem. They're going to give you three sides. They're going to ask you to plug these in and see if the Pythagorean theorem works. Again, I'm going to assign the short side to A, the middle side to B, and the longest side always is C. Then I am going to plug this in. 8 squared plus 16 squared. Does it equal to 18 squared? We're about to find out. So 8 squared, that's 64. 16 squared is, according to my calculator, because I'm not going to crunch that out on my own, is 256. Probably should have known that. 18 squared, I definitely don't know by heart. It's 324. Okay, let's add these two and see if indeed it works out according to the Pythagorean theorem. And 64 plus 256 is 320. Close, but not quite 324. So nope, doesn't work out, which means whatever triangle these three sides form, it's not a right triangle. So that's the answer to 22. That's all you need to do. Finished. So thank you very much for watching this. Hopefully this helps you out. If you have any other questions about any of the other 4 problems on the homework, please ask me in class. There we go. Thank you.